Okay, good. Thank you. Let me know if my screen is visible. It is, right? All right. Think we are now good. So, welcome to Introduction to Statistics. And in this course, we are going to we are going to cover uh, 8 topics. Okay, we are going to cover 8 topics. And we are going to start with the descriptive statistics. And I know most of you have interacted with the descriptive statistics on daily basis. When we talk about mean, when we talk about that is measures of central tendency, measures of variability, and also measures of asymmetry, all those are under descriptive statistics. And from the that is from the term descriptive, or we know we can describe. Okay, from the term descriptive we have describe. So descriptive statistics will generally give us a summary, okay, of your data set. If we are given a data set, then we do the like a summary analysis of it. Now that is categorized as what? Descriptive statistics. And under descriptive statistics, as I have said, we have 3 major measures. That is measures of central tendency. And under measures of central tendency, we'll discuss more about mean, which is the simple average. We'll also discuss about the median, and the median, it is the middle value in an ordered list, okay, or in a sorted list, either in a descending or ascending order. And then we'll also discuss about mode, okay. And for mode, mode, it's the most occurring what? The most occurring value or values in what? In a data set, okay. Yes, I usually like to use illustrations. So here we'll discuss about measures of central tendency. Okay. Also, we have another one which is called measures of variability. And under measures of variability, we have what we call range. Okay. And range, that is, we know that range is given by the highest value minus the lowest value, okay, in a data set. It's like max, that is max minus what? The minimum in a data set will give us now what we call range, okay. Then we also have what we call variance, okay. We also have what we call variance. And under variance, we have, of course, we know that from the definition that variance majorly shows us how far our data points are away from the mean, or how is our data set or our data points spread from the what? From the mean. Okay, so we shall discuss also on the variance. And the other measure in measures of variability is what we call standard deviation. Okay, yes, standard deviation. We shall discuss all this. Okay, we shall even come and discuss how we compute variance and standard deviation into what? Into different that is types of data, either population data set or a sample what? Data set. Okay, meaning with that we'll also discuss about what? Different types of sampling. But let's first of all cover the descriptive. I'm just introducing the that is the course. So we shall also discuss another measure known as measures of asymmetry. Measures of asymmetry. Okay, and under measures of asymmetry, we will discuss that is about skewness. Okay, we'll discuss about skewness, and we'll also discuss about what we call kurtosis. We shall see under kurtosis how that is the thickness and the thinness of the distribution tails. Okay, in comparison to that of normal distribution. Okay, generally we shall define what is kurtosis. Good. So that will be under descriptive what? Under descriptive statistics. Then we shall come and discuss that is regression analysis. Here, majorly we will focus on simple linear regression. Okay, we'll discuss majorly on simple linear regression, but I'll just give like an overview of multiple linear regression and logistic linear regression. I'll just give you an overview, for you will discuss more on this when you will be doing now the machine learning topic. All right. Then under sampling, we shall also discuss about all the sampling methods. Four of them. We have simple random sampling method. We'll also discuss that is cluster sampling. We also have stratified sampling method, and we have another one that is another one method. uh, okay, when I remember it, that is I will let you know. But we are going to discuss the four major what sampling methods. Okay, all right. So in fact, this will be what? This will be our second topic. We'll discuss it even before we can now start our discussion on what? On measures of variability. Because now under here we will have to define what is population data, what is a sample data. Okay. All right. Now we will also discuss that is things to do with correlation and also covariance and see the difference. We'll also discuss about inferential statistics and distributions. Okay. We shall now combine all this. And you know from the term infer, okay, like it's like you are making a conclusion, you are making a decision, okay, out of some findings. Okay, so with that, we are going now to discuss that is inferential statistics, and we'll also do exploratory analysis. Just an overview of what? Of our data set, how our data set looks like, how that is all the variables, if we have that is the variables we have, the data types we have. We shall also do from the term explore, that is explain, like exploring. Okay, we'll be exploring our data set. Okay, then after that, we'll be also doing, after every topic, we'll be doing some practicals. Okay, and these practicals will majorly use Excel. Okay, we will use Excel, but don't confuse that is analysis with Excel and the practicals of the statistics in Excel. So what we won't be doing the data analysis, okay, in Excel, but I will be showing you practically when we talk about standard deviation. How can we compute standard deviation in Excel and also in a manual way? When we talk about mean, how can we compute mean? Okay, in a manual way and also using the inbuilt Excel functions. Yeah, so we shall be going, that is the two what? The two methods. The manual way, okay, it's like the paperwork calculation, and also we'll do what? we'll also do do the other practical using now the Excel inbuilt functions. Any question before I can now start with the first topic? Any question? I hope all it's clear, right? All right, good, good. Nice. So, before you do even any analysis, or before you do that is you work with statistics, okay, the first thing to understand, or the first thing to you should know, it is the data or the data types you are using, okay, the types of data which you are using in your data set. Is it maybe do we have like continuous data? Do you have discrete data? Do you have qualitative data? Okay, whereby when I say qualitative, I majorly that is mean is your data a nominal data or an ordinal data. Okay, and before that, can someone define data? What is data? What do you understand by the term data? Someone, please. Someone who is willing, you can raise your hand. Yes, yes, Aheni.
Yes, I would say data is information that has not been processed yet.
Oh,
So
yes,
raw
yes.
information.
Right, right, right. That, in fact, that is a very simple and complete, very simple and complete definition. You've said data is unprocessed information, which is very, very correct. Okay. On my side, I can say data, that is data, I can say data or raw data. It's they are facts or figures which have not been processed to information. Okay, because when you have the raw data, it must go through processing. Okay, for it to now get, for us to get what, the information out of the what, out of the data. Okay, so basically we can define that data as facts or figures which have not been processed to what, to information. Okay, all right, or we can say they are figures and facts that when processed, okay, we get what, we get useful information. Okay, so maybe let's see what our notes are giving us. So data is defined as a systematic record corresponding to a specific quantity. So basically, data can be summarized as set of facts and figures which can be used to serve a specific usage or purpose. Or we can say the best definition is that is a set of facts and figures that when processed, we get what? We get information. Okay? Right. So, for instance, data can be used as a survey or an analysis. So, like for example, if we are doing a survey or we want to, let's give we are working with an online what? With an online dealer. Like let me find a good example. Maybe uh, you have an online, let me call it outlet, okay, where you sell your products. So with that, and you also have different social media platforms, okay, which you advertise, that is your products. So we can, with the data, or when we extract that or mine the data from your system, it will be able or will be able to know, okay, will be able to know which maybe social media platform did we get what? Did we get from which social media platform did we get a majority of what? Majority of the customers. Okay, because also in the that is on the uh, online that is ordering platform, you'll also indicate, you can also add a feature which will show maybe this customer add us maybe through WhatsApp or through LinkedIn or through Facebook. Okay, so with that, with the sales and also the customers channel, you will be able to now do an analysis. Like for example, if we let's say we have FB, we have IG, and we have maybe Telegram. Okay, if maybe your customers, maybe we had 10 customer add you through your Facebook page, and let's say 50 add you through your Instagram page, and let's say 100 had you that is all knew about you through Telegram what channel. So with this, you will be able to tailor that is your advertisement. Okay, depending with the social media channel. Okay, so you'll be able to now do more of your advertisements what in Telegram. Why? Because most of your customers, okay, are knowing about your platform, your products through what? Through your Telegram channel. Okay. Yeah. So those are just surveys and analysis which maybe we can do. So let's, the other thing is that data in a systematic and organized form is referred to as information, which is very correct. So when we now, that is systematically process our data, the end result is what? Information. And now it is on that information that you'll be able to do what? To make decisions. All right. So in addition to this, the source of data might be either primary or secondary. Okay. Yes, so those are the sources, that is the major sources of data. It can be primary source, meaning maybe you did some field work, okay? Maybe to interview people about your product or about maybe that is uh, candidacy or like opinion polls. You can as well um, go to the field to collect the opinion polls about maybe a certain system in the government. Okay, so that now will be a primary source. Okay, but what if maybe we are extracting maybe the data from a website where we had some companies or other that is other companies collected that data and posted on the that is on the websites or in different websites. Like for example, we have the Yahoo where we can finance, where we majorly extract that is finance data. Okay, so that will be a secondary source of data. Why? Because that was not your original data. Okay, yeah, I think this is so basic. We even learned this back in high school. Okay, yeah. So otherwise, I want us now to go direct to the different types of data. And maybe can someone give me That is the major two types of data we have. Someone, the major two types of data we have. Yes, we have Mulamba Michael.
Yeah, we've got qualitative and quantitative data.
Okay, maybe are you in position maybe to give us the difference?
Okay, just from my little knowledge, quantitative is numerical in nature,
Mm-hmm.
whereby if you look at maybe the height of someone, okay, that is quantitative data. You can put a numerical value onto it. Then
No.
you've got qualitative data, which is mainly based on attributes that can be observed,
Okay,
okay,
okay. Yes.
from a certain data. Yeah.
Very correct. When you talk about attributes, you have in or characteristics, you have already defined the qualitative data because qualitative data majorly shows us attributes, okay, and characteristics of a certain maybe feature. And for new, that is quantitative from the term quantity. We are talking of numerical data. And then under quantitative data or quantitative data, it's further divided or categorized into two. So, which are the major two categories under quantitative data? Someone? Yes, Jesse?
We have discrete data and
Mhm.
continuous data.
Okay. Can you maybe differentiate the two?
Or for discrete data,
Mm-hmm.
mainly categorical data, which holds infinite number of possible value,
That
and
is?
that's for discrete data.
Uh-huh.
For continuous data, it holds infinite number of possible values, e.g., maybe a weight of a person.
Okay, yeah, that's correct. That's correct. So I'm going to start with that is the quantitative data. Okay, and as you can see, we have discrete data and we have continuous data. Okay, Jesse has defined well that is the difference. So under discrete data, we can say this is we have finite data. Okay, meaning it is what? Countable. Countable. Okay, and for this cannot be in decimal. They are always whole numbers. Okay, like for example, when I talk about maybe in this class, how many statistics students do I have in this class? Okay, but I can see you are very many than I expected. Okay, all right. Okay, so like I can say I have 25 students. I have 25 students in this statistics class. Okay, so 25 is countable. All right, and 25 is whole number. I can say we have 24.5 students or 24 and three-quarter students. No, it's either 25 students. Okay, yeah. So with that, it's countable and it has no float attached to the value. But now when we are talking about continuous, okay, when we are talking continuous about continuous, we are saying it's infinite. Infinite meaning it's not easily countable, not countable, not countable. not countable. Then we also say that it has a decimal attached to it, decimal attached to the values. Okay, like for example, we can say it is a float in nature. It has a float in nature, meaning it has a decimal attached to the, that is, to the value. So like for example, when we are talking about students height, it can be 5 point that is 6, maybe let's say we have 1.5 meters, we can say 1.6 meters, 2.1 meters, that is the height of someone. We can also say someone has a weight of maybe 36.8 kgs, okay, maybe 62.5, that is kilograms. You can see we have a decimal attached to what? To the values. Okay. Yeah. And we are saying it is not countable because if I tell you maybe to count for me the values between 0 and 1, between 0 and 1 we have more than million values. Okay, we have more than million values between 0 and what? And 1. Like for example, 0.00001, it's a value between 0 and 1. 0.11, it's a value between 0 and 1. 0.00000001, it's a value between 0 and 1. So we have very many values between 0 and what? And 1, which occur that is in float form. Okay, so that's why we are saying that for continuous data it's infinite. Okay, not easily to be counted. Okay, I hope that that is clear and we are together under the, that is under the quantitative type of data, right? We are all good, guys, under that topic. Good. I can see some responses. That's awesome. It means we are all together. In case maybe you are left, maybe, or I skip something, or and you wanted to know that is about it, you can always as well write on the chat, or you can raise your hand for me to give you that is a chance to ask. All right, now let's start. I want us now to briefly that is discuss about the quantitative data. Okay, an in-depth discussion and see what we have on that is on our notes. All right, so quantitative data can be measured and is not just observable. Okay, so the measurement of the data is numerically recorded and what? Represented. Calculations and interpretations can be performed to obtain that is results. Okay, meaning you can do some calculations. Okay, yes, and this that type of data, it's numerically recorded and represented. So numerical data is indicated by quantitative data. For instance, data can be recorded about how many users found a product satisfactory in terms of collected ratings. Okay. Yes, like for example, we can know maybe how many people rated 5 star, how many people rated 4 star. Okay, this to show that is the level of satisfaction, meaning they are well satisfied with the product, and also with yes, with your product. Then we also have a 1, okay, and 2. Generally, this means that is we have some users or some customers who were not satisfied by what? By your product. Okay. Yes. So we have some examples, and we have daily temperatures. Of course, this is a quantitative data type, and we can categorize it as what? Continuous data type. Then we have price. Also price, it's continuous. Weight is also continuous. Income. Do we receive income in whole numbers? Yes, I guess so. Income can be discrete. Okay, income can be discrete because it is rare to find someone maybe is being paid, let's say 90 thousand point what? Point five. It's rare. It's either 90,000 maybe, or 55,000. Okay. So income here I can just categorize with what? That is under under discrete. Okay. But in case it comes maybe to your final exam, and it is presented with a decimal, then don't confuse that. It will now change to what? It will now change to continuous data type. Okay, let's start with the discrete. So discrete data refers to data values which only attain certain specific values. Discrete can't attain a range of values. Yes, we don't have range in what? In discrete data. Like for example, a range is like saying we need values between 0 and 2. You can see we have more than a billion, okay, values between 0 and what? And 1. All right. Yes. So discrete can be represented by using bar charts. We have bar charts. I know that you know that is the bar charts. Okay, these are the bar charts. And even when we'll be discussing that is about distributions, okay, you'll come to find that discrete distribution, we usually represent them in what? In bar chart form. Like for example, we have Poisson distribution, which is a discrete distribution. We have binomial distribution, which is a discrete distribution, and also uniform distribution. Okay, and all these we usually use the bar charts or column charts to represent that is the data, or to represent the distribution. So that's why we are saying discrete data can be represented using bar charts. For instance, ratings of a product that is made by the users can only be discrete. Yeah, so we also have other examples like the number of students in a class, the number of chips in a bag, and also we have that is the number of stars in the sky. You can say we have 20 and a half, that is stars. Okay, it is tricky to say that. We can't say that. Okay, then we have continuous data. Okay, and under continuous data, um, that is continuous data, we are saying that can be contain or can contain values between certain range that is within the highest and the what? The lowest value, as we had defined. Range is given by highest value minus the lowest value. So values, this interval can be termed as what? As a range of data. Continuous data can be tabulated in what we call what? Frequency distribution table. So we usually have something we call frequency distribution tables, and these are types of data presentation. How can we present our data? That is, we can do that using different graphs or charts, and also different tables. Like for tables, we have cross tables and also frequency distribution tables. Okay. Then for the charts, we have bar charts, we have histograms, we have pie charts, we have Kobo charts. Okay. We also have stacked and cluster, that is cluster charts. Okay. We have very many that is methods of or charts to represent data. Like for example, when we are talking about that is a frequency distribution table. Let's assume maybe you are working on that is German machine what selling let's say company. Okay, and we know we have Mercedes and German machines. Okay, and we have that is particular sales in a certain week. So let's say last week you sold 20 Mercedes. Then we have Audi. Okay, we have Audi. Audi maybe you sold that is 20. Okay, and then also we have the BMW. Okay, BMW. Okay, and maybe you sold 40 of BMW. So basically this is what? This is a frequency distribution table, because it is showing us the frequency of what? Of your cells. And okay, and with this frequency distribution table, we can also come with what we call relative distribution, like a probability. Okay, yes, just or a percentage or a proportion to show in percentage to show that is the sales of the different that is brands. Okay. Yes, so and with this you can always get that is the proportion or the probability, the probabilities, and also you can also do a cumulative what frequency maybe distribution. Yeah, but we shall do or discuss that. That is on a later topic. Okay, good. Now the frequency distribution table can be computed for the range type, that is range type of data. It can be depicted using histograms. Okay, like for example, the heights of students in a class can be largely vary in nature. Okay, so we can do what? We can summarize maybe the heights, even the age. Let's say we have in not only that is heights, but also edge. Okay, but for edge, let's keep it as a discrete, but as well we can do what? We can also make edge to be a continuous that is data. Like when now we are saying maybe you are two uh, like you are 2 years and 3 months old. Okay, yes. All right, now we have some examples. We have some examples. So we have height and weight of a student. It's continuous in nature. Then we have daily temperature recordings. Uh, yes, they are also continuous. We also have wind speed measurement. Okay, wind speed measurement. It's also what? It's also continuous in nature. Any question? Any question about the discrete? That is about the quantitative data types. Any question? Any question on quantitative?